So. Can you hear me now? Let's see. Yes, I am audible now. Very good. And now I'm also visible. Perfecto. Good evening, Chip. What's up? Oops. That was not the plan. That was the plan. Good evening. Back. Yes, I am back. And we are going to jump straight into the electronics stuff. First though, let's select a different lighting, like this, maybe a little bit brighter. Good. All right. We switch to the display capture and jump into keycard. And here I need the LT1512. Okay. Screen monitor. So I have another thing. Today we're building a charger, a little battery charger thingy. Let's just recreate this one here. There's someone at the door. Be right back. And I am back. So, okay, so I need to first create the symbol for the new charging thingy. So let's do that. We start with pin number 1 VC, and VC seems to be a input, even though this pin is going to send some stuff out. Next pin, feedback, FB, pin 2, input. Feedback goes to the side here. We're just rebuilding this one here. GLDS, or wait, no, EFB, pin 3. Just place these things somewhere. Soft start, pin 4, in, 5, ENDS, 6, 7, and ESW, 8. So these two are power. Just call it passive. Because just power pins. How is your weekend, chat? I hope you are having a good weekend. Here. Side. Just the switch output. Go in. Go in here. Input soft start pin goes here. Here, so. Save X, and we switch back to the schematic editor. LT151, and I forgot to add the footprint, and we are going for the 8-pin PDIP package because I have seen this chip available for $625 from Reichelt. We're also going to check if we can get it elsewhere. 1512 LCSC. Just in case we need to get it from LCSC. About eBay. 3-piece for $1660. No. Okay, so we are going for the EDIP package. Restposten. Okay. They only have a limited amount of parts available. Wix, hi. Hello, what's up? First YouTube viewer. So we need a standard PD package. Oh, not this one. No, why not? Why not this one? Looks good. 7.62 millimeters with long pad. Then how about some? So we need some resistors. We need capacitors. And inductors. Inductor, fuse, and a thermal fuse. There no symbol for thermal fuse in keycard? So strange. Okay, I'm online, says the Discord. I would hope so that the Discord says that. Alright, what do we need? Ah, wait, I need a special type of inductor here. A coupled inductor. Cooler. Inductors. Power inductors. Okay. And we need coupled. Let's see if we can find coupled inductors. No. No coupled inductors here. Parts. Okay, nano henries. Yeah, we don't need nano henries. We need these are all not coupled inductors. These are all regular inductors. We can build it. Really? That late? Let's see. Let's see. Was that really that late? 2028. Yeah. Wow. Why is that bot so late? Late Mistkäfer. Saturday is the most traffic on Twitch, you see? You say, or where? What do you mean? With most traffic? Okay, so let's jump back in here. So I need the data sheet. How do we select that inductor? Okay. L1A and L1B are normally just two identical windings on one core. Although two separate inductors can be used, the typical value is 33 microhenry, which gives about 0.25 peak-to-peak inductor current. Lower values give higher ripple current, which reduces maximum charging current. 15 microhenry can be used if charging currents are at least 20% lower than the values shown in the maximum charge current graph. Charging current. Here, maximum charging current. So we are going to use 0.2. So we need definitely probably. Okay. Is there a formula on how to calculate the inductor? Nope. But they have a spreadsheet program. Okay. Let's see, software resources or documentation, design knowledge. No. Supporting materials. Nope. Component. Nope. Okay, they have a demo circuit for LT Spice. It's helpful. Lower current, so we go lower in what was this? Lower current means lower inductance. Machen Sachen. Niki, moin. Na, was geht ab? So, ich kann diese Musik nur sehr empfehlen, by the way, Audiofinity. Guckt sie euch an. Der Canvas im Auto macht Mecker. Okay. Was denn für Meckerkram? Okay, jetzt finden wir das Ding bei JCPCB. Okay, it is available hier. Welche Viecher? Was ist das? Footprint? Very expensive. What type of inductor is this? Categories, inductors, coils, chokes, power inductors. Okay. Manufacturer Eaton. Tempomat schalten. Okay. Hast du was, um den CAN-Bus anzugucken? Kannst du dir die Signale auf dem CAN-Bus angucken? Beziehungsweise check mal als erstes. Also als allererstes Ostsee Hasse, sehr gut. Also CAN-Bus. Also optimalerweise sieht das so aus wie die rote Linie, das Signal auf dem CAN-Bus. Was du aber haben kannst, ist, dass wenn irgendwo eine Terminierung kaputt ist, dass es eher so aussieht. So mit völlig krassen Überschwingern oder irgendwelchen anderen Dreck. Oder aber du hast schlichtweg irgendwo einen dreckigen Wackelkontakt. Ringing square is not good. Ja, that's definitely not good. Also du sagst Standheizung, Tempomat und Scheibenwischer machen Ärger. Was hast du denn für ein Auto? VW, ich gehe mal VW ein. Okay, also der Scheibenwischer hat ein Steuergerät. Dann hat er Tempomat ein Steuergerät. Und... Ah ne, warte mal, du hast gesagt... Scheibenwischer und Tempomat funktionieren nicht. Und die Standheizung auch nicht. Okay, also, so wie es aussieht, Steuergerät, Wischintervall, Scheibenwischer, hat wohl auch irgendwas mit dem... Könnte natürlich sein, dass das Biestviech ein Steuergerät hat, direkt hinter dem Lenkrad. Opel Vectra, okay. Opel Vectra. Okay, also das ist definitiv dann hier die... Also es könnte an der Unit liegen, ne? Die hinterm Lenkrad sitzt und die Blinker- und Scheibenwischerhebel kontrolliert oder abfragt und das dann weiterleitet. So, da würde ich anfangen. Lenkrad ab und alle Kabel einmal überprüfen dahinter. And yeah, you have to know the impedance. Yes, of course, but to know all that, that's not so easy to find out without all the documentation. What you can do though is you unplug the battery and then you use an LCR meter, for example this one from Benuzi, to find out what is the impedance of the CAN bus. However, it would be best if you have something to compare it against. Nur für den Fall, dass du irgendwie Reflexionen auf dem Bus hast, dann kannst du dann sehen. So, wenn du da irgendwie, wie gesagt, komische Reflexionen auf dem Bus hast, dann weißt du, dass irgendein Gerät ganz am Ende des CAN-Busses sich verabschiedet hat, weil dann die Terminierung nicht mehr richtig hinhaut. Oder du hast einen Kabelbruch. Also, du jagst ein Signal auf die Datenleitung. So. Und dieses Signal bewegt sich auf der Datenleitung mit Lichtgeschwindigkeit innerhalb des Kabels. Wenn es jetzt an einen Kurzschluss trifft, dann wird dieses Signal komplett weggefrühstückt, was dazu führt, dass an einem anderen Punkt im System die Spannung erst steigt und dann absackt. Wenn alles die richtige Impedanz hat, dann sieht das Signal so aus. Wenn aber irgendwas nicht richtig hinhaut, dann kann es so aussehen. Aber da die meisten Sachen noch funktionieren, würde ich eher davon ausgehen, dass der nicht so wirklich der CAN-Bus abraucht, sondern dass da eher irgendeine Unit, wahrscheinlich die Unit hinterm Lenkrad, dass die Scheiße baut. So, we are not going to use a coupled inductor because way too expensive and also too hard to find. So we are going to use just 2 inductors, 33 microhenry, and we're going to use the same ones that I used yesterday. So we want the, what is that, MCD something. Or was it CSD? CSD something something. CDS? Okay, what was the name of these inductor footprints? Let's see here. Subfan footprint. MSCD. Yes, okay. We are using those. So, and MSCD. Components. MSCD 32. Okay. So 33 microhenry is what they recommend, and that is what we are going to install. Yep. Okay. Maybe even 22 microhenry. No, we're going with the 33 microhenry. So this is going to be MSCD paste. So deactivated. Paste. Braucht man das eher selten. Also ich benutze mein Messgerät jetzt nicht so häufig. Aber es ist schon praktisch. So. Hopefully, for the tabs. Okay, so ceramic capacitors, 2.2 microfarad, and we're using the 1206 footprint hand solder, because this board I'm going to hand solder. 2. Rod. No, am I going to hand solder this? I don't know, maybe. Maybe I'm gonna hand solder it, but maybe not. I don't know. So we're using 2 in parallel, just because better. 4.4 microfarad and extremely low ESR. Was? Die Nachricht darüber? Was? Was meinst du, die Nachricht darüber? Achso, hast du noch was geschrieben? Scroll. Ach so, die Standheizung. Ja. Ja, das ist das, was so ein bisschen eigenartig ist, ne? Wenn das nur die Scheibenwischer oder so wären, dann wäre das ja ganz klar, aber dass die Standheizung halt auch noch irgendwie Le Problem macht, das ist jetzt wiederum so ein bisschen eigenartig. Da weiß ich nicht, warum die Standheizung da zickig ist. Einzige, was ich mir so denken kann, ist, dass die irgendwie mit irgendwas da so zusammenhängt. Aber in welchem Zusammenhang das steht, keine Ahnung. Das ist... ja. Weird ist das. Das ist aber auch ein gutes, ein guter Punkt, dass du keinen Fehler siehst, weil das bedeutet, dass der CAN-Bus selber noch okay ist, würde ich jetzt mal sagen. Also zumindest würde ich mir das jetzt so denken, wenn ständig irgendwelche Daten auf dem CAN-Bus im Auto zerhackstückelt werden, weil da irgendwie die Datenübertragung nicht richtig läuft. Das würde ich jetzt sagen, das sollte die die Autoelektronik erkennen und das melden. So. Da sie das nicht tut, würde ich jetzt eher davon ausgehen, dass die Elektronik selber in Ordnung ist. Also der CAN-Bus selber in Ordnung ist und stattdessen die eigentlichen Sensoren oder halt Schalter, dass die ein Problem haben. We only need one of these capacitors. No need to put two. Sure. Nur mal überlegen, was das alles noch sein könnte. Was da das Problem verursachen könnte. Aber mir fallen nicht so wirklich viele Dinge ein. Chat, do you... Naja, also ich würde das trotzdem erstmal das Lenkrad überprüfen. Und dann kannst du immer noch weiter gucken. No, I mean, chat, any one of you have any idea what could be the problem with Nikki's car? The wipers are not operating properly. If he enables the wipers, they go twice instead of once. And what was that? The speed regulator is not engaging, and also the heater is not properly working. So, what could be the reason for all this? Auxiliary heating and cruise control, yeah. So, and you already put the OBD reader there, and it didn't show you anything. What type of capacitor do I have? So, since there's no errors, I would suggest so many through-hole capacitors here. Since there's no... What do the sensors show? Yeah, true. Nikki, try reading the raw data from the sensors. Try reading the raw data from the sensors. Maybe they give back values that are not really, that are still plausible. So the computer is thinking these are okay values, and therefore is not logging an error. Yeah, or when you flick the switch for the Viper it actually does give it 2 quick pulses in rapid succession, even though you only specified 1. So we have a radial capacitor, 4mm in pitch, with a diameter of 8mm. Okay, 8mm diameter and a pin pitch of roughly 4. Could also be 5mm. I don't know. 8mm. Radial pin pitch. No, this is all SMD stuff. I need through hole. THT. Not axial, but radial. 3.8mm pitch. 8mm diameter. Exactly that one. And this is 220 microfarad. 35 volts. And then we put another one of these coils there, and another one of the capacitors as an extra filter stage, because this is going to power the depth sounder, and that one is extremely sensitive to noise on the power supply rails. Okay. Screw terminal? Or? No, we don't use screw terminals, I think. Going to use JSD pin connectors. Connector 2 times socket. Transform mirror. So this is thermal fuse, and this is normal fuse. Or how was it? No, first the normal fuse, then the thermal fuse. Let's look for a nice used 300 milliamps. Disposable fuses, thermal fuses. So let's see here. Auxiliary heating requires yeah, good point, good point. plug in pin pitch 5 millimeters. Okay. This is for thermal fuse. Whoa. Fuse. You see. Looking for something with a pin pitch of 5 millimeters.
There is no heaven left for me. She is my faith, my prophecy.
This could be it. Let's use it for now. Use. I mean, this is with pins, so we can always just place it. And a standard disposable fuse. Current rating 315, 350, 375 and 400. Something that is in stock and le cheap. 4 cents for a 0603 fuse. Maybe a little bit too small. 0603. Again, 0603. Okay. And we are going to use that 0603 thing. So, what do we do with the soft start pin? Sync and slash or shut down. This is a thermal fuse. Let's put this little note here. Note. And 2 fuse. Protects against over temperature. Primary fuse has a trip current. So we are using which one? 375 milliamps. This one. So and it'll burn. And that's the thing. That's what I have. So 250, 375, so 400 milliamps. 400 milliamps should, yeah, so this one will be able to conduct 400 milliamps for 10, 20, 30, 40 milliseconds. Not milliseconds, seconds, 40 seconds. That's the danger with these fuses. And if there's something in here, seriously overheating, then the thermal fuse can kill the power before this one burns up. That's in case something, for example, since this is charging a battery, also the battery could become too hot. So this fuse would protect against battery overheat. If the battery gets to, I don't know, 100 degrees, this fuse will open the circuit. So I want these to be JST XH. Because the JST XH connector is quite nice. So let's see. Okay, the diode has no footprint yet. I'm going to use one of my diodes from my parts box here. MBR 2045. 20 sounds like 24. MBR 2045. It's probably not enough, although the 20 could also stand for current. 2 amps. Let's see. MBR 2045. 45 volts, 20 amps. Yes, we are going to use that. Huh? What? Wait, moment. Ah, okay. Could not reach network controller. Aha! Could not reach... no, could not reach network controller. I mean, that is interesting. Yeah, why didn't it log this error? That I would put to... that I would like to ask the Opel engineers. And the answer is probably was too expensive. So we have manufacturer part number none. Right. C 21 6 6000. Okay, C 21 6. Okay, that's a D26 60 volt.
I'll fall too far. I'll drink you dry. I'll leave a scar.
Okay, it's a 60 volt 2 amp Schottky diode in ZOT 123 package. Six.
Black velvet veins, you let me in.
2 amps 60 volt. SRP 1, 2, 3. And the footprint is soft 1, 2, 3 as well. Ja, aber wenn er sagt, er kann den Netzwerk-Controller nicht finden. Nee, das glaube ich ist eher, dass der Bot, dass das Auto versucht, also der Hauptrechner versucht, die Standheizung anzuquatschen und kriegt von der Standheizung keine Antwort. Und der Grund, warum der das nicht als Fehler loggt. Okay, so I have a theory. My theory is the main computer in the car is trying to talk to the auxiliary heating unit and cannot find the auxiliary heating unit. So the software in the computer just assumes that the auxiliary heating unit is just not installed. Great. I think it's a plausible theory. So let's see how small we can make this thing. That's the thermal fuse. Main input fuse here. Next would be the first coil. Oh wait, no, the first part after this is the input capacitor C5. Yep. Sounds like a plan. Why do on Monday? Why not do tomorrow? So, coupling capacitor C1. L2. Output capacitor and create output buffer cap. filter coil. And second output buffer. And then the output connector. Position. Okay.
Too many years, too much decay. The sun no longer warms my skin, but dusk remains where I begin. I chase the dream of mortal fire, of beating hearts and soft desire. But every step just led me back to graves and
Okay, how big is this thing now?
let me fade into the dust. No need for
57.75 millimeters. Okay, so tomorrow is Sunday. Yes. On Sunday you can work on the car, right? So let's make it 60 by 30. Oh, that's no 60 by 35. Because using that, line width 5.2 millimeters. With this size, I'm definitely able to put a microcontroller on the board and have that thing control the charger and, for example, disable charging. No need for a logic analyzer. Just the oscilloscope with a lot of memory, and if possible a CAN bus decoding function. Unless you have one of those cheap PC based USB logic analyzers, those can help as well.
no song to sing, but dust still gives me everything. It wraps me in its hollow light and lets me rest without the fight. So tell the world
Okay. I'm going to add a microcontroller, 80 tiny 85, because those are available in 8-pin dip package. So What do we need? 7805 L. Maximum input voltage 30 volts. We don't need a lot of power, all we need is okay, let's see here. So both will be one macro forward. One F. One F. Pin assignment of this thing. So pin 1 V out. Yes, of course this is wrong. V out on pin 1. Wait. You could also use a 1117. Why is the 7, 8 XX regulator switching? What? We don't want switching regulators. Regulator linear. So, regulator linear. There we go. 78L05. So you'll have nice 5 volts, regulated 5 volts, and some power, and we can here use this pin to number 1, disable the charger, and number 2, set a different frequency for the charger, for the switching frequency, which is definitely a very good thing. So, and then we put what type of thermal sensor? What is the name of that sensor? LM39 or 35? LM39? No. LM35. Okay, so and that means we need a connector with 3 pins for this chip. Number 1 is 5 volts. Pin number 1. So, pin number 1, 5 volts. Then, and we're going to filter the 5 volts a little bit with a ferrite bead and a capacitor. 1 microfarad. And pin number 2 is temp sense. That then goes into the microprocessor. Let's just put it in PB2. Let's see. Start.upmail.com. Going to check, create new project, 80tiny85. Oh, 80tiny. The 80tiny85 is not listed. This is ungut. Are they discontinued? Arduino pinout. Okay, pin 5 and 6 can create PWM.
can keep her far from me. No prayer, no spell, no rosary.
Okay, so these two we're going to use for the solid start pin. Let's go with PB1 because on PB0 the AREF pin is there and we might be doing something with that. And then of course the reset pin needs a pull up to 5 volts. And just because I've made that a habit, put a capacitor there for decoupling or for filtering. Rather. So. Okay, and then pin number 3 of the sensor is round. And the ferrite bead. Don't forget the ferrite bead. Ferrite bead, small symbol. Yes, this is all part of the charging system for the little battery that is powering the depth sounder on the boat. Because we want a redundancy for the depth sounder, because it's next in terms of priority, compass, depth sounder, and then the rest basically of the navigation equipment. No, not for my boat, for the boat of my parents. And no, I'm not building a sonar. That is way too expensive, not expensive, way too difficult and way too expensive to build it yourself. If you want a side scan sonar, for example, you can get a full package for 649 euros. I have no chance of meeting that price point when I build it myself. No chance at all. Okay. Update. Wait, before we update, we first have to do this. AST, XH, 3 pin, and the ferrite bead is a generic 0805 ferrite bead. I think I have some of those flying around somewhere. This is a 10 Okay. Ohm resistor. I should place, also have a button there.
Is what I do.
Just a simple tactile switch
Used to scream, I used to dream,
for reset.
but now I haunt my own regime. I wear the cloak of what I was, but can't remember.
This is some Omron generic switch. No, not those. No. Button. Button. Whoa. No, not those. Single pole. Dark hook. Huh?
Is what I do.
What the heck?
I broke the sky to taste the flame. Now stars fall
That's the nice thing.
silent at my name.
For 649 euros, you get the display and the sensors.
Don't speak or stay. They faded while
That's why I say it's impossible to beat that price point. Absolutely impossible. So I'm not even going to try. Single floor switch. Why is there no...
I'd bleed it dry, but even pain has passed me by. I gave too much to
here it
gain
is.
too less,
Okay.
and made the void my one caress.
Okay, now I can update. So we put the charging chip, charging controller in here. Make a little bit more room to the side so we can fit the charging controller and all its accompanying circuitry. Number R1. One is gonna sit here. Right now it's going to be sitting right in there, so I need to move this a little bit down. R2 will sit here.
The fire in me doesn't burn. It freezes everything.
R5,
A frost that
C4.
glows with silver grace.
Yes, that's why it's so difficult to build one on your own. Because it's an array of hydrophones. First, I don't know how to make hydrophones watertight without compromising the sound. Then no idea how to, yeah, basically how to do any of this. So yeah, as I said, I'm not even trying. I'm not even going to try. I'm just going to buy this, or my dad is going to buy this, and then we will install that sonar thingy on the boat, and that's it. Nothing more. This pinout sucks of this chip. Okay. That's not a very good pinout. At least not for the way I want to build this. Okay, I can make it compact, more compact. So then put this resistor here. Oh wait, this resistor can sit here. This resistor here. Once we can make this more compact, can save it maybe a 1 or 2 centimeters even. This is the spot. Nice. We are able to make it smaller. Oh, aha, right, of course. First the diode needs to be placed somewhere in here. Okay, and then all these resistors and other components placed here next to the chip. And then we got the CPU. maybe we can set the CPU sideways like this. And this set button here. Oh, that's okay. Wait, we need a different button. Tactile switch with different. Oh, what? 2 errors? Okay. Error. Pad 4 not found and pad 5. Why is that an error all of a sudden? Update. Okay, I mean this error is okay, we can ignore that error. Huh? What? No. Edit symbol. 1 3. What? Okay. Spell changes. You know what? I make this simpler. I'll just load from a previous project, so I don't have to fiddle around with the symbols or footprints or anything else. Water controller, I/O, nope, CPU. There, copy, paste. What? Copy, paste. Oh, okay, this one seems to be too old. This should work. I know where we get this. Battery discharge protector. Because I have the buttons in here. One button. Where is it? There. Copy. Paste. Hey? Ah, wait. I have to paste it into the schematic, of course. Then update the PCB. Now it works. Okay, so the mini power supply for the processor is sit here. with its 2 caps. That was the capacitor for the processor. And the right bead for 5 volts. As part of this thing. What else? The reset stuff. Okay.
I set the world alight for pride, but watched it crumble from inside. The ones I loved, I turned to stone, and now I sit and fade alone. So let the kingdom turn to ash, let memory erase the flash. I walk away, I don't look back. The crown is gone, the soul is cracked. No fanfare now, no final moan, just dust upon the broken throne. I end not with a scream or flame, but silence where they knew my name.
I think this looks half decent. It lacks the mounting holes. But that's something I'm going to fix now. So I want 2 mounting holes. Screw terminal. Nope. Mounting hole without pad. Unconnected.
I sip on red that isn't wine and velvet
So 2 mounting holes should work. One there, one here.
it shows no spine,
And
just
if I
empty
put this capacitor like this, this button further down.
still hum my name. They mock the silence with a sneer. The portraits play their ancient game of staring back with doubtful fear. I don't sparkle like
Okay,
lace, and I
this.
night and day. Painted lips, sarcastic sighs, living dead with bedroom eyes. Toast to love that lost its bet. Here's to red wine and regret. I haunt the cafes after 2 in vintage boots and dead boy dreams.
Hey. These mounting holes will be M3.
Complains I never call, but wax is pale when I appear. I write sad poems on castle walls and rhyme immortal with cold beer.
Have a little bit more room for the processor. Put it down. We can move these a bit. And then this there. Anywhere else? Where I have this here. Here. C6. Let's see. Any other places where we have issues? Nope. I think we are ready for routing. So, ground plane. Top and bottom. Front copper. Front and bottom copper connected to ground. With 0.2, 0.5 and 1 millimeter. Constraints, none. All on standard. 0.5 millimeters for power. Then vias next to each ground connection. And next to each ground pad of some capacitor. These get 2 vias. It's power. Here we need 2 cells because we need to sneak between the pins. And we need to find a grid. Okay. Then all the sense lines. And now the last one. Almost the last one. Yeah, well, this is not high power. There's no high power stuff going through here anywhere. This entire circuit is designed to run, to charge at 250 milliamps and nothing more. So I want this signal to be on the top side, because this is going to be the only somewhat high-speed thing. And now we need some ground vias to stitch together all these planes here. Although, no, I don't really need the ground vias here. I don't think so. No, not really. I have all these signals on the top layer, and they all have a clean ground plane underneath them. So no need to place too many ground vias. Or, let's place at least some anyway. And also set the clearance to 0.25 instead of 0.5 millimeters. Yes. 0.25. Thermal relief gap 0.5. Yeah. Set. Yeah. 10 wires act as inductors, but in this case I want inductivity. I want inductance. At least, for example, here I want actually at least some inductance. So here we need some ground vias. Yeah, basically we go here, and then we have next to it the grounds. Yep, that looks good. And let's take a look. How big did I make this? Oops, we need to do this in user comments. 47.5 by 32.5. That is very small. small enough for what it is supposed to do, and that is just charge a little 1.2 amp hour lead acid battery. Okay. Okay, so we have one thing that we need is a good ground path from here to here. And we have this power goes through here. But I could improve this by just placing vias here. So we have ground underneath this, then jumping over there. On the other side, and then from here, going there, going here, into this, and yeah, okay, this works. No excessive ground loops. Alrighty. One millimeter per amp. Wow. Okay. What was my rule of thumb? I think my rule of thumb was more or less, if it's more than an amp, I use planes. But sometimes I also just check what the temperature or the thermal, yeah, how this would behave thermally. And then that is my benchmark that I say, okay, it may get to this temperature so I can get away with smaller, or I need to use bigger wire or even copper planes. Okay, so I just saw something. This needs to be built differently. This needs to be built like so. Needs to move here, then over there, because we need a short ground path from here to over here. So because from here, so we have basically we send current through this coil, and this is the ground return path here, and yeah, I think this needs to be close here because basically the current is flowing from here, from ground, through here, through this coil, into this diode, and then out. This could create some radiation, some EM radiation. But I'm too lazy to redo everything now. If it gets too noisy, I always can... You know what? We're changing the mount holes to ones with pads, with ground connections, so that I can just, if there's way too much noise being put out by this device, then I can always just make the case conductive. And just shield the entire thing. So M3. Oh wait. M3 with lots of pad yes in it. Bottom, where's this thing? Filters with yes, okay. Or should we use this with VIA? Yeah, we can use it, I think. Most important is that the vias inside these mount holes are not smaller than 0.5 millimeters. Otherwise, the production cost will rise a lot. Because then I have to suddenly start manufacture a high precision board, and I don't want that. But these vias look big enough. Yep. So, in case anything here radiates, I put all of this just inside a metal cage. The amp battery is 1.2 amp hours, so the charging current will be around 200 to 250 milliamps. So no problem with traces like this. Put on silk screen B2B charger. $250 milliamps current. 5.5. This is revision A. Paste. Connect and verify sensor to J3. So now we need the pin designations, power, so power, let's just place it here, power, sense, ground. Line King, hello. Thanks for the follow. So this is the pinout for that thing. Power to sense ground. And here I'm just marking ground, I think. Yep. You just started learning electronics. Ah, that's good. What toys are you going to build? And welcome here to electronics and flight sim, which I'm going to switch to now because I have basically finished this. I have not done any of the calculations for the part for the part values, but since I'm going to hand solder this and use only parts from my part boxes, I can wait with the calculations until the day the boards arrive. Yeah, exactly. What have you built so far, Lion King? So, let's jump in our little bonanza and do some cargo flying. How do we change? I mean, easy to change in... Uh... 3D print parts that combine like Lego pieces or something, so you can put them together. The Eligu kit. Okay. What is in the Eligu kit? Ah, Arduino starter kit. Okay. Like this. Wee. That's a lot of stuff. Some 7-segment displays, LCD display, motor, Arduino of course, servos, nice. Touch sensor, moisture sensor, keypad, relays. It's not a touch sensor, it's a RFID scanner. Oh, that's cool. Hmm. What a lot of stuff. Yeah, I also started with a kit. What was that? There was a Kickstarter. I don't know how long ago. 10 years ago, maybe 15 years ago. A Kickstarter for cheap Arduino clone. Let's see, Arduino clone Kickstarter. Mega 3. What's that? 34 something. This is 17. No, that would be too late. No. 32, 4. It was a Leonardo clone with a white board. That's what I started with. I don't find it anymore. May have been 2012. I think it was 2012. Could even be 2010. It was some, as I said, it was some Arduino clone board, and that Kickstarter project went absolutely through the roof and smashed every stretch goal. And the stretch goals were some additional stuff like sensors and other things. Yeah, so in the end, yeah, for 10 euros you got the Arduino clone board, you got some sensors, a few resistors and stuff. Really a starter kit. So we need the 80 times 85, 2 times. And LM35s. What the hell? What? 5 euros? For an LM35? Really? Why so expensive? These freaks. Ah, there we go. 75 cents. That's more reasonable. Clear these expensive beasts out of this. I don't need high, ultra, super monster precision. All I need is basic precision. 2 or 3 degrees precision is more than enough for this. The other one was for 5 euros, yeah. And I am going to buy 2 of every part. so I can assemble 2 of these boards. I think I still have some L78L05 regulators, but for 18 cents we can just get 2 more of those. Doesn't matter. Everything else I have. Maybe except for the fuses, I don't know. Okay. Actually, I do have a company. Nogitaka Services. But yeah, I haven't done that yet. But yeah, I could order samples, that's true. Alright, so time to do some flying. Today with the Bonanza A36 turbocharged. And we need to get from Tromsø all the way to... what was the name here? First we need to get to Leknes and then from there to Rost. So ENLK to ENRS. So I need a little bit of light in here. Lights. Avionics Master. We need the tablet. Since it is cold outside, which we can look here on the transponder, -4 degrees outside air temperature. We are going to just leave the cowl flaps closed. Let's put the payload in the plane. Okay, so there's quite a few people who want to... Quite a few stuff that needs to be ferried from Leknes over to Rost. Which means I'm going to... Norway got snow yesterday. Yeah, I believe that. I've seen quite a bit of clouds moving to Norway, yeah. Okay, low bus volts. Yeah, that's probably because of the computers and gyro and everything else using quite a lot of power. Okay, now the gyro is on. Gyro vacuum pump. And we're closing the doors. Oh, first we leave the pilot door open so we can listen to the engine when it starts up. Okay, so number 1, we run the aux fuel pump low for 4 seconds with full rich. 1, 2, 3, 4, and a little bit of throttle and start up. That didn't start. Yeah, fuel everywhere. We just give it full throttle Well, before we start engine and stuff, let's first make the airplane full with the cargo. All cargo, okay. So we will have 48% of fuel on board. Okay, so I'm going to fly just direct with the GPS. So, what is our... And of course I need the Navigraph charts. By the way, earlier today I saw there was a big procession of airplanes going from somewhere around here to Helsinki, and then from Helsinki to Hamburg. And as you can see, Hamburg is yeah, it's quite a bit of activity today. So, any activity here where I am? Not really. We have one guy, Phil, flying a 737 from... Ah, no, he's arriving just now. Oh wait, there's a few more. The SAS pilot from Tromsø, no destination, and NOZ 3PQ, no information. Okay. Let's add my information. We are flying from Tromsø via Evani and RST to... Well, first we need to get to ENLK, to Leknes. Good. So we just have Evani. Right is how much? 1,304. And we need as much fuel as possible. Do not let me crash the airplane. I will try my best. But no promises. So let's get weather information via ATIS 126.13. 126.13. Outside temperature 4, -4, dew point. Okay, 1007. Okay, and we want the tower. So, the flight has been generated. And, oops, I forgot to set the right number. This would be Nogitaka 36, because we are in a Bonanza 36. Okay. New flight for say intentions. Tromsø Tower, Nogitaka 36, IFR to Leknes. All set disable. So we need a little bit less fuel and a little bit more payload. Okay, departure runway. I request IFR clearance to ENLK. So we have our fuel, we need the payload. I need 400 more pounds, so let's add a few pounds here. There we go. Okay, we are still beyond the aft limit. That's not good. But me no care about aft limit. This thing will fly anyway. So, what is the... that is 2975. Okay. 29. Oops. 75. Enter, enter, approve, acknowledge. Flight plan. ENTC. Next flight plan. Let's load up this one. Cursor. ENTC from Sir Ivani. Enter. ENLK. Enter. And we want to use this flight plan. This is set to GPS. We need to select a course of 222. There we go, 22. Switch this to 1. Fair enough, 1. And start tracking. Okay, let's fire this thing up. We need to connect the... Yeah, I'm going to connect the Say Intentions AI thing. Let's see here. Stream kit, Say Intentions AI. Connect Twitch. Disconnected. Dashboard.
Also Tower Scandinavian 69 Charlie with information Victor
Live.
requesting IFR clearance to Oslo.
Okay, let's try to start the engine again.
Oslo via the admin for Alpha departure, departure runway 36, initial climb 10,000, departure on 123.755 squawk, 2711 Scandinavian 69 Charlie. Bravo, traffic service not available. Contact Trump for departure for radar services. Which frequency?
Probably at some point. Taxi lights on. Landing lights Stay off right now. Nogitaka 36, request taxi to runway. Alternator is on, and we have a quite low battery.
Nogitaka 36, runway 18, taxi via Yankee Echo.
So, all doors closed. Kevin, let's get some heat in here. We'll open. And release parking brake. Flaps 1. It's not really flaps 1, it's just approach flaps.
Cabin attendants, armed doors, and
Oops.
cross-check.
Wait.
Welcome everyone on board on behalf of
We
Nogitaka
don't have
Airlines,
a
the captain and the
cabin crew on this
to
flight.
witness. My name is Mara Maya.
Because this is just a small airplane that is a little bit tail heavy. So I really have to take, be careful with the Piper. No, this is a Beechcraft Bonanza. Nogitaka 36, ready for departure. Going to do a little bit of a shortcut here.
Nogitaka 36, runway 18, wind calm, cleared for takeoff.
As you can hear, this thing has a little turbocharger.
Good afternoon, Colt 11, information Bravo, holding head with Colt 12,
Okay.
destination port close, under flight flowing, ready to copy.
Max power.
11, Tromsø Tower, hello, pass your message.
I want the maximum
Good
horsepower.
afternoon, Colt 11,
Yes.
information Lima, holding hands with Colt 12, destination port close, airport base, requesting flight
Yep.
following.
This little turbocharged engine has some power.
Colt 11, clear to destination, 1,000 feet, maintaining below PFR below 1,000 feet, squawking 4765,
So,
departure frequency 123,
Gear up.
decimal 755. And Colt 11, ready for takeoff.
And now we are going to just, at first, just get some speed. 140 knots, and once I have achieved that, I'm going to start a climb. There we are. Autopilot engage, nav mode, and can start dialing in the altitude, engage altitude. And 11,000.
4079, requesting IFR clearance to Oslo.
Oh no, 12,000 is a good number.
Oslo by the Amin ground departure runway 18, climb flight level 090, departure 123.755,
RPM's back a little bit.
for Scandinavian 4079.
1200. Wait for the RPMs and the power reading down here to stabilize, and then I'm going to adjust the
Contact
mixture
departure
a
on
little bit, so we get
123.755.
power. Or we go for less fuel consumption. Fuel consumption of 200. 28. Manifold pressure. off to see the mountain I'm about to fly into. Okay, we need to contact departure. 123755. Departure, good evening, Nogitaka 36. Climbing through 2,000 feet for 12,000 feet. Need to squawk 1235.
Nogitaka 36, Tromso departure, not seeing you on radar. Double check 1235, ident again.
Hit the ident button.
Nogitaka 36, Tromso departure, identified 7 southwest of Tromso at 2200 feet. QNH 1007, climb flight level 090, vectors to Evany, then as filed.
Exhaust tubes are glowing a little bit. Oops, I am creating a sauna in here. That wasn't the plan. So let's reduce the heat a little bit.
Scandinavia 4414, can we confirm any speed restrictions on approach?
Scandinavian 4414, descend altitude 6,000.
Departure, this is Scandinavian 4411, requesting IFR clearance to Oslo Beyond Information Sierra, sorry.
Stand by for that clearance.
Yeah, we are a little bit slow. And also there seems to be a lot of wind here. Let's get a little power here out of this engine. Maximum gas temperature.
I am working on that clearance. Stand by.
So the first hardest one. So we have a little bit of a imbalance right now. We are draining the left tank. We should instead drain the right tank. And also move the fuel from the wing tanks into the internal tanks. Cylinder head temperatures. Cabin pressure is also good. Yep, we can continue to climb to... It would be at 9,000.
Guido 845, contact Polaris Control on 126.7.
Polaris Control, 126.7.
Alright, how far to the destination? Well, to the next waypoint. 50 miles to the next waypoint. Time to load up the flight plan. So other people can also see what I'm doing here. I can climb a little bit faster, 1,000 feet per minute. Don't need to simulate an A340 here with the slow climb rate. Be right back.
Level 270 with the 5 Romeo Whiskey. Climb and maintain flight level 350 with the 5 Romeo Whiskey.
With Air 5 Romeo Whiskey, contact Polaris Control on 126.7. Lufthansa 879er, climb flight level 270.
Climb flight level 270, Lufthansa 879.
Lufthansa 879er, contact Sweden Control on 131.055.
Contact Sweden Control 131.55, Lufthansa 879, good day. Tomso departure, Nordic 396, 3000 to 9000.
Nordic Nordic 3906, Tromso departure identified, climb flight level 090.
Climbing 090, Nordic 396.
Nordic 3906, climb flight level 260.
And I'm back. Perfectly timed with the ad break.
Nogitaka 36, Tromso departure, contact Polaris control on 126.7.
Polaris control, Nogitaka 36, light level 090.
Nogitaka 36, Polaris control identified. Good evening.
Sorry, approach. No shuttle 76 Echo, acting road, setting level 158 on the approach.
No shuttle 76 Echo Polaris control identified. Good evening.
Polaris control, no shuttle 386 with you, 155 down to 4,500.
No shuttle 386 Polaris control identified. Good evening.
Okay, let's see here. Normal checklist. No.
Polaris control, this is Piper 352. We have begun our descent. We are descending to 9,000 feet.
Piper 352 Polaris control identified. Good evening.
Polaris control, this is Piper 352. We have begun our descent to 9,000 feet.
Polaris control, Oscar Yankee Sierra Oscar Tango, descending to 7,000, crossing 17,000.
Ah, yeah, cruise, okay. 2,500. Heat on, nope.
Give me 1 second for that clearance.
I'm searching for the tables. What I should set for an engine. 25 inches manifold pressure, 75% continuous power. We should go. Okay, so fuel flow 100 and between 105 and oh, right. The fuel flow is in gallons per hour, and in the table it's in pounds per hour. That's it. That's it, yeah. Okay. How many pounds is 1 gallon of aviation gasoline? Avgas 100 LL pound per gallon. Okay, 6.02 pounds per gallon. So 105 divided by 6.02. I should be burning 17 gallons per hour. A little bit lower than that. So let's go up to 17.5. Less there. The engine makes 241 horsepower, and we can stay comfortable at 165-ish. Okay, how do I compensate for temperature? Avionics. True airspeed indicator. Airspeed indicator. Which can be positioned for pressure, altitude, and air temperature. Okay. Yeah, okay, how does this thing work? Der Grasi hat mir gerade geschrieben. Was macht er die ganze Zeit?
Scandinavian 255, Polaris Control, contact Avianaise approach on 120.1.
Mein Bier ist alle. Here is empty. Coca-Cola.
Scandinavian 414, Sweden Control. Good evening.
Okay, so let's see. How does this? What's this called? An E6B flight computer. See.
Bowie 1, Mike, arrival at the Tromsø and run ready, descent flight level 330. Object 9.5 feet. Descend and maintain flight level 150, object 9.5 feet.
Object 90953. Descend and maintain flight level 150.
Descend and maintain flight level 150, object 9.5 feet.
Okay, so how does this thing work? Chat, anyone knows how this thing works? So ground speed 180 knots. So we have to just dial this. Line altitude, or what is this? And then move it over here. Or minus 5 degrees. Or how does this work? I don't know. No idea how this thing works. Waypoint. Yeah, half a mile.
Oscar Yankee Sierra Oscar Tango Polaris Control identified. Good evening.
Control, Alpha Tango 44, hello. At flight level 1 to 2, climbing to flight level 2 to 0.
So,
North Flight Tango 44, Polaris Control identified. Good evening. Let's get a few more horsepower out of this engine. Why is my exhaust pipes not blowing? Want them to blow red hot? Maybe we should switch off the air conditioning system. Just regulate by using the heat. So we get a few more knots out of this airplane. Seems like a tiny bit of fuel. Sit and there we go. That looks good.
Nogitaka 36, Polaris Control, contact approach on 123.755.
Approach, this is Nogitaka 36 on flight level 090.
Nogitaka 36, approach identified. Good evening.
It's the Andoya Airport approach, okay? We're flying next? Are we flying close to Andoya? By the way, I'm going to send my Aerostar, the one that I have here in Tromsø. I'm going to send that to ENLK or ENRS as well, because there seems to be quite a bit of cargo that we can move around, and I want to fly the Aerostar a little bit. Okay, so we got... Well, we don't really have a lot of stuff that we can move over there. At least not stuff that the AI can fly. Okay. Star. One of the other pilot. Because fuel at these points is expensive. In ENLK the fuel is not that expensive, but in ENSK the fuel is expensive. Why not? Because I am in a small airplane, and this small airplane of course has no cabin crew. But yeah, this is definitely the wrong plane if you want to go to Tokyo. I mean, you could go with this plane to Tokyo, but it will take a very long time. Well, we can... I can try and do something like that. Wait a second, chat. Let's go flight tracker. If you go exclamation map. Can share a flight. That would be only the flight URL for this particular flight. I don't know if I can share a link to my profile, to my Volanta profile. Let's see. So this would be the flight. So if we now, well, let's see. So this would be the now go to user profile. Then yeah, okay, that works. Copy. Let's try this. Moin Grazi. Nagitanka 36, yes.
Widrow 845, turn right, heading 250.
It's heading 250, Vidro 845.
So now with this link you can go to my account, and then when you click on online now you can see there the current flight that I'm doing, and then you can just zoom in. So many that started from Hamburg. Let's see. Oh yeah. Seems like today was a very busy day in Hamburg in Flight Simulator. Or no, wait. When you click on that link, then of course you will see a lot of flights from Hamburg, because that is my main departure point. I usually fly from, not usually, but very often I fly from Hamburg, of course. Hamburg, Bergen was also for quite a while I often flown route. But recently I've now fly very often from Hamburg, and for the winter months when the north is nice, cold, icy, and all this stuff, I'm flying the northern bush flying, so to speak, from Tromsø. Grazi, was machst du? What is you doing, Grazi? Okay, so let's see here the navigation charts for Leknes ENLK. Charts approach. Guess we will fly with 110 at 020. We will fly an approach for runway 20. Okay, that is an RNAV approach. Meaning we need a few more waypoints in my 348 is the
Nogitaka 36, descend altitude 6600, turn left heading 205 vectors for the RNAV runway 2 approach, QNH 1002.
descending to 6,600 and heading 205 vectors for the RNAV approach. Nogitaka 36.
Nogitaka 36 approach, descend altitude 6000.
6,000. Descent 6,000. Nogitaka 36. And want to fly 205. That is 210, 205. Turn on landing lights. You turn on the landing lights. Wie viel Battlefield hast du schon gezockt? Battlefield 6. Okay, I think we can land there visual, I think. Bei mir packst du ein Komma zwischen die beiden Zahlen, zwischen die 5 und die 8, glaube ich. So, let's go down to 150 horsepower. 17 manifold pressure. TMK, you can also do exclamation mark instead of crew message. You can use ATC message. Yeah, exclamation ATC message. Works. Let's see if I can. That works. For that, you have to do exclamation mark arrival 80s, for example.
Everyone, your attention please. Let's recognize our 5 most recent Twitch followers: Lying K1NG, Uncle J Pop, Chicago Superman, Bushcutter 1234, Potential Bliss. Hey everyone, your attention please. Let's recognize our 5 most recent Twitch followers: Lying K1NG, Uncle J Pop, Chicago Superman, Bushcutter 1234, Potential Bliss.
Runway 2? With a wind of 1110? No, that would be a bad idea. 10 wind. Yeah. Can I get runway 20 or Legness? Because with the wind at from 110, I cannot land. Let's get the ATIS arrival.
Nogataka 36, runway 20 is not active. Only runway 2 is available for Lackness approach.
Only runway 2. Okay. Copy that. Runway 2. I typed this in the wrong way. Arrival ATIS. Like this. Yes. So for runway 2 we can actually use a localizer. That is very helpful. 354 and the localizer frequency is 108.5. Okay, so let's dial that in. 108.5. Set. And the course is 354. Was geht hier? Doc, was hier geht? Die neue Black Square Bonanza befliegen. Feststellen, dass ich ein bisschen sehr wenig Power gerade drin habe. Da müssen wir mal korrigieren. Vollgas! Ui, Alter, was sind das hier für eine Turbulenzen? Das wollen wir uns mal genauer anschauen. Diese Turbulenzen. Show 3D Thermal. Ah ja, ja, okay. Sowas schmeißt einen natürlich dann ganz schön durch die Gegend. Was ist das hier? Weather. Was sind noch Options? Debug. Muss eine Möglichkeit geben, hier sich mal die Turbulenzen anzeigen zu lassen. Und ich meine, ich habe das schon mal gesehen, dass irgendwer das hingekriegt hat, sich Turbulenzen anzeigen zu lassen. Naja, egal. Das ist ja eigentlich falsch. Wir wollen nach 2.05 fliegen. Und was hältst du von der Kiste, Alter? Was ist das für ein Wind hier? Ist ja schlimm. Das ist an der Regel aus dem Sitz. So, switchen wir mal auf GPS Nav. Nicht GPS Nav, auf Nav 1 Receiver. Ja, wir sind auch schon bald am Localizer. Am Initial Point, C1-Punkt. Was fliegst du im Moment, Doc? Ich meine, ich habe dich vorhin gesehen. Du warst irgendwo unterwegs in Südamerika? Jetzt C750. C750, das ist die Citation, ne? Oder? Oder welche? Ja, genau, die Cessna Citation, oder? Das schnelle. Ich meine, ich habe da doch. War das gestern? Station X. Da hatte doch. Ich meine, Cessna, die hatten sich irgendwie einen Spaß gemacht und mit einer Cessna Citation X eine Global verheizt oder so. Muss wieder weg. Alles klar. Denn bis demnächst mal so, wa? Jo, danke sehr. So, ich wollte ja nur mal den Direction Finder eindrehen. Alter, was ist das für ein Geschüttel hier? Ist jetzt schlimm. 4, 8. Switch. Okay. Okay. Let's fly over there. Heading 205. Das fliegen wir doch schon die ganze Zeit. Heidi. Müssen wieder mehr DCS fliegen. Ja, auf jeden Fall. Ich habe auch eigentlich 1, 2 lustige Missionen ready, aber beziehungsweise eine Retribution habe ich ready, aber das geht ja ohne ein paar Leute geht das ja nicht. Da braucht man ja ein bisschen. So. Request course change to 300 and altitude change to 2000 feet. Let me talk about 36.
Nogataka 36, climb altitude 2,000 feet, turn right heading 300.
localizer. We would like to join the localizer for ENLK Delta 36 and land there now.
Nogataka 36, ENLK has only RNAV approach for runway 2. Turn left, heading 180 vectors for RNAV runway 2 approach.
Runway inside, request visual approach. Navigation mode.
Nogataka 36, expect the visual approach runway 2. Report established.
Established on the visual approach for runway 2. Nogataka 36.
Nogataka 36, roger, continue visual approach runway 2. Report when established on final. Nogataka 36, 3 miles from the approach turn. Turn left heading 335, descend altitude 3000 until established. Cleared for the visual runway 2 approach. Nogataka 36, Leknes Airport at your 1 o'clock, 7 miles. Change to advisory frequency approved. Report cancellation of IFR or missed approach this
Okay, switch to advisory. And we're coming down like a dive bomber from the Second World War with everything extended. So how do we do the approach? We are going to the 2-mile marker, and there we have to be at 1,200. And then we fly this one from 2 miles, we fly manually. Okay. So we need to be at 1,200. 4 miles, from 8 miles. For the power. Maybe not so much. Seems like we have a lot of wind here, a lot of crosswind. Landing lights on, taxi lights on. The pumps on. There's the 2-mile marker. Descent. Wow. This wind is blowing me all over the place. Wind 110 at 24. Okay. That's gonna be interesting landing. Jamie Moin. So, and now from here we continue the flight to ENRS Rost. But first we are going to unload a little bit of stuff and load a little bit of stuff. ENLK to ENRS. So, we're not refueling here. This place. Why is that Airbus so damaged? Today is Saturday evening, so that means all my aircraft are getting maintenance. Something is wrong with my 727 though. It is sitting in Santorini and it's not doing anything. Why is that? Because there are 2 flights waiting there and the AI doesn't know what to do. Ah, okay, the aircraft is overloaded again. Why is it always overloaded? So stupid. Aircraft overloaded. Why? Why is it overloaded? Eh? Thought I changed this. Save back. I was very sure that I changed this. Something reset that change. So, how do we fix this problem? I guess we will just fly the 727 to Hamburg with not quite everything on board. So we need to split it off. 600, 22. To 150. Okay, so back to Hamburg, back to Santorini, to Hamburg, and here we need to remove 1,300. That is 22,700. Eh? Eh? My math isn't mathing. What is this? Stay here. To move 1,300 and 800. Cool. How much do I need to remove? 500. 182. 700 minus 522, 200. Okay. Oops, well, that was a little bit too much. Okay, and the rest needs to be brought over by a different airplane. Which one? 717 plus 700 plus 600. 7 plus 700 plus 600 is 2017. Okay, so send it. And the starship is sitting again in Tromsø. That is a problem. The starship would have the capacity. I think I need to get an airplane in Santorini. Chat, I need suggestions. What airplane am I going to get in Santorini now to fix the issue with the cargo that was too much for the 727? Tell me, I need to know. What are we going to use there? But only small stuff. Yeah? No monster, big, I don't know what crazy thing. And it needs to be able to transport this. What is the smallest jet here? The Kri jet. What is that thing? MSFS Kri jet. Okay, let's look at this. What is that? MSFS Kri jet. What is that thing? Two model airplane engines. Okay, that is kinda stupid. Yeah, and about the Antonov, yeah, of course the Antonov could transport this, but these heinies here have not updated it for Flight Sim 2024, so it is broken, not working anymore, which really sucks. Very annoying. So, I don't know. before we wait in this menu here and spend too much time there, let's continue our flight with the Bonanza. We want to go to ENRS now. Let's see how we can navigate there. We can just fly from... Okay, let's try navigate with just the ADF beacons. So we set this as origin and set ENRS as our destination. And we need to fly in a way that the ADF beacon on 338 is sitting at 215. Charts. So ENRS has runway 20 with a guided landing. The landing system. That would be nice. Also a non-directional beacon, just fly there at 215. Okay. Let's go. What was that? 338, right? Yep, 338. Uh-oh. I think the battery is empty. Yes, it is. Oops. Let's see if we can start the engine. I don't think so. Yep, no chance. I completely killed the battery. Gallons. Magnus fuel is cheaper than Ross. Okay, then we are going to get some cargo. How much? 600 cargo would be available, but we don't have that room. Or well, we don't have any of these jobs that offer that much. Update. So 1 packs, we need 1 passenger and some extra cargo. What is my cargo, by the way? Electric generators, okay. So basically the passenger back there has to share the space with some Honda generators or something. Okay, payload. Let's move these two. Validate fuel, let's go. Just add 6 gallons to the fuel. Into the outside fuel tanks. So, and we need to increase the payload a little bit. Okay, we need to add another 60. Oh, that works. Start tracking. Let's see if this engine fires or if it's a little bit flooded. close. Mixture. Okay, we had one ignition. Just heading for the runway instantly. No tower that is operating here. And frequency 338 on that thing. And we'll take off in what direction? The other direction. Something to do. Get ready, I mean, get some temperatures. Throttle. Dial down the mixture a little bit for maximum power. I want 300 horse. There we go. From here, we want to fly 215. Autopilot engage. Heading. My altitude will be 8,000. Engage arm with a climb rate of 1,200. My target temperature suddenly 30 degrees. That's not really what I want here. I don't want sauna again. Okay, that mountain there doesn't look too inviting. And we are just being pushed around like crazy, so we're going to fly on the right side of that mountain. then we go back to our original course. That was kinda close. 30 degrees in the cabin in the game. Here you can see this. So there's no real regulation. I have a cooling unit down here, and I have a heat exchanger that transfers heat from the exhaust manifold into the air that is being blown into the cabin. And both you have to basically find a balance with this valve here, this one, to get a certain temperature. And the higher you climb, of course, the colder the air that is going into the system, and as a result, the colder it gets inside the cabin, or the more hot air you need to supply to the cabin. So much wind here. We need to climb higher where there's less wind, less turbulence. Receiver is not receiving anything on that frequency yet. What range this beacon has? Range of power 25 to less than 50. Okay, so somewhere between 50 and 25 miles we will start receiving, and then also seeing the green needle, I think, move towards the destination there. My minimum decision altitude is 420. Where's the other airplane? The Aerostar. The Aerostar has almost arrived in ENSK. It's in approach mode. How fast is that thing already? The Aerostar Aerostar speed 210 knots. And the Viper I fly, the Bonanza I fly here, the Beechcraft. But that's interesting. This airplane I fly right now is 6 knots faster, and also can carry just 90 pounds less. 110 pounds less than the Aerostar. Probably because one engine here in this airplane at the front creates almost as much power as the 2 engines in the Aerostar, Piper Aerostar. Piper Aerostar is sucking in 22 gallons per hour. The Beechcraft Bonanza is using 19 gallons per hour. Over there is the island. Yes, I am mistaken. I think, yeah, no, I think that is not the island yet. Because otherwise we would definitely see this on the ADF already. There, I have an idea. I mean, we have Bodo with the look with a VOR at 117.5 megahertz. So if we add this to the route, this is 54 miles on the radial 280. So let's dial this in here. We have frequency 117.5, right? Or NDME, let's check. Receive it yet. 7.5, switch. No reception of that thing? What? Okay, next is radial 280, distance 54. Also the other one. 117.55. There we go. And also the ADF has now reception. Check. Yes, so here, this one, and done. Runway there. that airport has basically nothing. ENRS, Open Airport, weather information, 998. Yeah, the name of this airport is Röst. So we are going to descend now to 1,500 with a descent speed of 1,500. We are 14 miles. Now that I don't have hot exhaust gas anymore because I have dialed down the have reduced the power of the engine. Now it's getting cold inside the airplane again. I put more power in here. Hot air gets hotter. So let's just switch off the air conditioning unit. Runway looks short. This runway looks very short and small and stuff. So, since we now have a waypoint set, we can go for an RNAV approach. Yes, 204 degrees. This is 204 degrees. I'm coming in too high. So we drop the gear, we drop the flaps, and we increase the descent rate. Should switch to the other tank. One of my tanks is less than 1/4 full. White instead of red. This is the flight path now. is the navigation signal. All we have now is the directional beacon and Mark 1 eyeballs. Steep descent. Flaps. Preferably 110, and while we are descending here, the entire airplane turns into a sauna. 34 degrees already. But I don't have any time right now to take care of the heat problem. 35 degrees. And I forgot to turn on my landing lights. Is this a taxiway? No, this is just a turning spot where you can turn the aircraft. Okay. Okay, time to get this aircraft a little bit cool. Open pilot door. Okay, now that's interesting. I have opened the pilot door, and still the temperature is rising. Why is the temperature not just instantly going to ambient temperature? That is a little bit weird. Open the cabin door. Let's see what that does. Will that crash the temperature down? Nope, it doesn't. Light finish. That's off. Save some battery power. Pitot heat off. Vent blowers off. Fuel tank pumps off. Master avionics off. Alternators off. And lights off. Battery off. I thought fireworks is not allowed in Denmark. Some do it anyway. Where do they get their fireworks from then? From Poland, or at least that's here in Germany. If you want crazy fireworks, you go to Poland. "14 days before New Year's." Okay. Here in Germany, it's only allowed for only the week before New Year's, so only for 7 days. Okay, so we have brought the Germany to blame. What? How are we so responsible again for stuff like that? Okay, so the Aerostar is sitting in ENLK and needs something to transport, so we are going to do that now. And we fly with the Aerostar to Röst. Because that airport, navigating there, that is kind of interesting, I think. Okay, let's set this as the departure point, and we want to start. And in on-air company, I'm going to see what we can transport. We have perfume. We have some computing equipment and servers. And from ENRS to ENLK, what could we transport with the illegal fireworks is sold in Germany? That cannot be. We have strong rules against that. Why is the engine running? Okay, let's compare the engine analyzer of the Aerostar with the engine analyzer of the Bonanza after I set up the work order real quick for the Bonanza. So the Bonanza needs to transport some stuff from some people from ENRS to ENLK, so we can transport more stuff with the Aerostar. So this, this, and this. And I'm going to set this up in a way that we will send the Bonanza to transport as much as possible over to ENRS. So to split off about 85 pounds of these servers. So let's make it a clean 90. 1509 minus 90 is 1419. Good. Okay, so this is what the Bonanza is going to do. And the rest I'm going to fly with the Aerostar. So we want the perfume, computing equipment, and that stuff. Wow, okay. We can fit everything in the Aerostar. But I would have to dump a little bit of fuel. Okay, let's do it then. We have a range with a 30-minute reserve of 25 miles. Okay. Do it anyway. Because I know that perfect weather and we can do this. So, fuel and payload maximum. And let's fire everything up. We need the master avionics. Cabin lights, why not? So fuel, light fuel load, 14 gallons. On, and we need the 117.55 and down here this autopilot thingy, waypoint 1, that is radial 280, 54 miles. Well, you know what? We can also enter these points here, which, so we want to fly this, we want to fly the approach basically. So that means, right, how do we do this? I need Bodo as my reference point, and then I put this here, add to route after Bodo. That is 289, 53 miles. 53. Oops. Check. Okay. Use. This one is set. Next waypoint. Next waypoint would be here. Add to route after. clear out the first waypoint. 285, 54 miles. Ein Feuerwerk Hannover.de. Yeah, of course, indoor firework. Yeah, okay. I mean, I would be very surprised if they would sell proper outside fireworks for yeah, at this time of the year. That would be illegal here. Okay, so return waypoint 1 RNAV select 117.55, and we have a pressure of what is the pressure right now? ENG weather 100. So 100 is what in? Let's switch this mode over to metric air pressure. 0, 0. There. And then switch this back to normal. And that means we have an air pressure of 255. Is that 254-ish? 29054. 2954. Knowledge. So new flight plan. Cursor. Clear. Clear. Delete flight plan. Yes. Okay. Cursor. And okay. Enter, and RS502. And ENRS. That's the flight plan, but I'm going to navigate with VOR, and the GPS is just for confirming. Okay. A bit more payload. Baggage 400. I need more. Here. I need still more. 230 in the middle. Maybe 240. And here at the front we put not so much. 200. empty that seat and put everything, oops, everything in these 2 seats here, right, these 4 seats. 300, 300. Uh-oh. And the next airplane where I killed the battery. Okay. Let's have a look at the engines. Whoa. What happened to that engine? What the heck? What happened here? Oh, oil level 0. Okay. Well, seems like we have to refill the oil. And maybe we should also put in fine wire spark plugs. I'm going to clean. Whoa. Okay, so we are losing oil like instant. which to me means first need to replace the oil lines. Oops. Fix oil lines. Fix oil filter. Fix the magnetos. Fix the fuel lines before they start spewing fuel everywhere. Mechanical fuel pump needs to be fixed. Dry air pump needs to be fixed. Air filter. Alternator. Fuel injection and oil pump. Well, they are yellow, so technically still airworthy, meaning we leave it like they are. Left engine, let's see. Left engine looks very nice. I don't know what happened to the right. Why is the right engine again like this? Eh? Oh, because right engine fire. Why is the right engine burning? I have a right engine anti-fire button somewhere. Nope, I don't. Why is my right engine burning? Okay, so right engine has been reset and replaced. Hydraulic lines also replaced. No more right engine fire. Good. Let's give both engines full oil tanks. And fine wire spark plugs. Yes, because better. Okay, airframe. Let's see. Inspect. Okay, we need to replace that brake. Battery is low voltage, but that's okay. As long as we can start one of the engines. So we want fuel. Fuel pumps. Primary engines a little bit. We'll start the right one first. Are we flooded? Yes, we are flooded. That's one engine running. Okay, start tracking. Set the transponder to VFR, because that's when we are flying. We're flying VFR routes. And I have an idea. I want to fly the other departure here. Let's fly to the north. Instead of the south, and then turn and fly back to the airport. Wolf trying Danish beer today. Wolf? Who's Wolf? You mean Wolf Spain or what? Streamer. Hydraulic pump to get full hydraulic pressure. Oops, that was too much flaps. 20 degrees of flaps. And control. Power. Maybe a little bit too much trim aft. Needs to change. Yeah. Select the nav system. And here's the question. Yeah, okay, so we fly this direction now. Hey, why are we still climbing like this? We need some speed. Autopilot on altitude hold. And heading hold. Speed. Wow, okay. Going to this mountain range. I like that. 014. 014 is the direction. Okay. Time 060. And I would like to climb right now. To update the engine monitor. Faster climb. And we're receiving, so okay, 215. Direction. First we need not 215, we need this point, and 220, with 7 points. Then 224. Much smoother the Aerostar than the Mensa. But on the other hand, with the Aerostar, I always constantly have to adjust the where's this bullshit? Oh crap! The computer has forgotten all the data. Okay, that's it. So I have to re-enter all this data now. Another 553. So 253. Gia is calling. Hello, Gia. Still streaming, by the way. Yeah, I will go sleep. I will fly over there and then I will sleep. Are you watching? Yeah, I will go sleep after I land. It's not long flight. Good night. By the way, the music has stopped. We need some music. Because with music, everything is better. Oops. Maybe we are flying a tiny bit fast. Let's climb faster. So how cold is it on this airplane? 18 degrees right now. That's good. Dial in the temperature over here. Lower fresh air ventilation. Okay, we have a low fuel one now. That's nothing. That's the off at 7,000. something gallons per hour. And that's my 100. It's 2 minutes. Speed up rate for and the low fuel gallons. 10 gallons. Okay, so I have. Wait a second. My engines are sucking down 12 gallons per hour right now. I have 9.7 gallons remaining. Is that right? I have just 15 minutes of fuel life. Okay. Didn't expect that. Oops. Okay. Good. 37 miles to go. Somewhere in the theoretical range. Okay, we have 22 minutes of fuel remaining. Set these settings here right now. Please just tell me more. Okay, that's fuel peak. So 22 minutes remaining. Miles per hour, approximately 95 miles. 74 miles theoretical range. I'm going to land with just fumes in the engine all the place. I am a heater. Because the heater is using gasoline. Heater off, blower off. Temperature maximum. Maximum. The cabin right now a little bit, and then I'll turn the heater off. We have a full battery. Alternator on this. Can alternator. I have to say the engine analyzer here in the Aerostar has a tiny bit less functionality compared with the engine analyzer in the Black Square Bonanza. There's no information about boiler, and so depending on where the injector is, but yeah, apparently vapor fuel vapor tanks are not simulated here. It's blinking down there. And why is it blinking? By the way, tomorrow I will try to do GoPro stream. Not sure what I'm going to stream there. Maybe I'll run one of the engines I'm going to sell on my old off-road motor, just to basically make them fit for the winter. So I'm going to run an overly rich fuel mixture, make sure the carburetors are empty and the engines are well oiled. No, just preparing the motors for the winter, the outboard motors. We're almost at the final waypoint here. That's really good. Let's get between the center. Flying so far from us. See the airport. Watch. Let's fly ahead of us. Get better. And still trying to get good, I think. Up again. Won't be there ever. Max power. Second just that's the That's another runway night on my queue list. Is that big 737? Yes. good oil. That looks good.
It's not deceit, it's just desire. I breathe in truth and exhale fire.
And that oil looks good as well. Okay. And with that, it's time to end. Thanks for watching, guys. Hope you had fun. And I'll see you next time. We are going over to Oxymandy. And yeah, I'll try to stream tomorrow. Until then, thanks for watching. Bye bye. Good night.
When dawn redeems, I'll still remain a whisper, a mark, a lipstick stain. My mirror hums when I lean.
Yeah, I'm starving. Where can we eat? I'm so hungry. Thanks to Mel recommending me that one drink. One of Nordic said thank you for recommending the drink.
Fan 86 rated with 3 viewers.
Thank you so much for the raid.
Mixed trio.
Yeah, how is your stream? Welcome in. 9:30.